What's up, guys? Today we're finding the physics of throwing a football.
We're going to find the rotational velocity
and how hard to throw 100 yards.
We threw the football at a 45-degree angle because that gives us the most optimal maximum horizontal range.
This is the data for that throw, including the yards converted into meters.
First, we're calculating the initial velocity of our throw that went 28.346 meters. Since the throw was made at a 45-degree angle, the x component and y component of the velocity are equal. This means I only need to solve for the x component to find our initial velocity. And once I've found this x component, I can use the Pythagorean theorem to find the initial velocity of the throw. Now we're going to solve for the release velocity of my arm needed to throw it 100 yards. It might be a little unrealistic, but now let's calculate the initial velocity needed to throw the football 100 yards in the same amount of time as the 28.346 meter throw, which was 2.7 seconds. Since the time of flight remains the same, the horizontal velocity must increase to cover the greater distance. Using the same kinematic equation, but plugging in 100 instead of 28.346, we can figure out that the initial velocity needed is 33.867 meters per second.
To solve for rotational velocity, we will count the number of rotations and the time the ball takes in the air, and then calculate for the average velocity of the ball. With that throw, there were 8 rotations in 1.4 seconds, and the radius of the ball was 0.17 meters. Now that we have our variables, we can start solving for rotational speed. Our rotational speed can be measured by this letter, which is the Greek letter that is lowercase omega. Our formula is rotational speed is equal to the number of rotations over time. So here we have 8 rotations over 1.4 seconds. When you divide those numbers, you get 5.714 rotations per second. Now to solve for the amount of radians the ball rotates per second, we take our rotations per second and multiply it by 2 pi. When we multiply these two numbers, we get an answer of 11.428 radians per second, which is the speed the ball rotates in radians. Now the last step to find the velocity in meters per second. Velocity is equal to the amount of radians per second the ball rotates times the radius, which is 0.17. After multiplying these numbers, our final velocity is 1.943 meters per second, which is how fast the ball was rotating when I threw it.